Another is from a height 4h. So here basic formula you know it. Since it is freely falling, h here is half gt1 square, where 4h is half gt2 square. 4 times half gt1 square is half gt2 square. So 2t1 is t2. So t1 by t2 is half, which is 0.5 seconds. Here a machine gun of mass capital M fires n bullets per second, each of mass M. Here what he given is mass of bullet is M, initial velocity 0. So here the speed of each bullet is u, final velocity is u. So change in momentum is m into. So now here force exerted by the one bullet is rate of change of momentum. That is given that is per 1 second. The number of bullets so fired in 1 second is n. So force exerted by bullets on the gun is mnu. Here a disk of radius r is rotating with an angular velocity about an axis passing through the center and perpendicular to the plane. Let the IB moment of inertia of disk about an axis passing through the center and perpendicular to the plane. Now, a heavy point mass, small m, is gently attached to the rim. Then the final kinetic energy of the system. The meaning of gently attached, so no external torque, which implies torque is nothing but rate of change of angular momentum 0. L here is constant. Initial angular momentum is this. Now it has because this mass m is attached, its moment of inertia changes. So omega dash will be I omega by I1. So what he is asking, kinetic energy of the system of I1 omega dash whole square of I1 omega dash is I omega by I1 whole square, which is half I1 I square omega square by I1 square. So here I square omega square. Here I1 is nothing but, so once after placing a heavy point mass at the end, so moment of inertia is about a disk through the center of mass, and this is located at a small mass at a distance r. Moment of inertia of the system becomes this, then this will be the answer. So the ratio of accelerations due to gravity. So here it is, G is gm by r square. So here ratio of radius of the planet C given and escape velocity C given. So let R1, R2 be radii of planets. So R1 by R2 is x, and escape velocities of planets V1, V2. So we know that escape velocity is this. So I can write it as root 2 into root of gm by r square into r, root 2 into acceleration, root of acceleration into r. So that means v1 by v2 will be, let me write acceleration r1 by r. So v1 by v2 is given as y. Ratio of escape velocities given it as y. Accelerations. So this we given it as x, which implies a1 by a2 is y square by x. So here a spherical planet far up in a space has a mass m naught and a diameter d naught. A particle of mass m falling freely near the surface of the earth from a height h, the momentum of the particle when it strikes the ground. So here it is, falling freely means u0, v square is 2gh. It is near the surface of the planet. So acceleration due to gravity, much change won't be there. So v will be 2gh. So the momentum here momentum of the particle is mass into velocity. We know that uh, G is equal to gm by r square near the surface of any planet, where gm 4 by d naught square. So momentum is m into 4gm by d naught square into h. 2m by d naught, 2g, here it is the mass of the planet is m naught h. So fourth option is correct. So this one, the water column is held in a vertical glass tube as shown. Maximum mass of water which can be held by the tube. So here, water, obviously when it is in the capillary tube, it has to fall down. But still it is like that in the capillary tube, means weight of liquid column is balanced by force due to surface tension. So here it is. So in which direction surface tension force acts? Surface tension force acts along perimeter. So here angle of contact is theta. So here it is tension. This is angle of contact. Its component is t cos theta. Everywhere it acts along the circumference. So upward direction force due to this meniscus is 2 pi r into t cos theta. Similarly, because of this also, you have another 2 pi r t cos theta. So the net force acts will be 4 pi r t cos theta. For pure water, theta is 0. So the net force acts due to surface tension, which is balanced by the weight. So maximum mass means 4 pi r t by g. So maximum mass in since cos theta is 1. So second option is correct. Here it is. De Broglie wavelength associated with an electron having kinetic energy. Lambda here is h by p. So we know that kinetic energy is p squared by 2m. So this is lambda for an electron. So wavelength in terms of energy after substituting mass of electron Planck's constant, and after simplification we have a formula, Angstrom units. So this will be 150 by this energy must be in electron volts. It is 3 by 10 angstrom units. Point 3 is roughly 0.5 whole square is 0.25, 0.55 angstrom units. Here a proton of mass enter into a magnetic field with a velocity. Force on a charged particle is QVB sin theta. Here Q is charge of proton, velocity he given, magnetic field also he given, angle also he given. So it is 0.8 to 0.4 into 10 power minus 12 newtons. So moment of inertia of a cube. Moment of inertia of a cube about an axis passing through the center of cube is ma square by 6. But with coinciding with one of the side, moment of inertia of a cube of mass m about an axis coinciding with one of its side. So about this is one of the side. So here this distance is a. So this is a. It will be OB square is a square plus a square, which is 2a square. OB is root 2a. It is center. OC will be, we get a by root 2. So about this, I1 will be IC plus MR square. IC here is MA square by 6 plus MA by root 2 whole square. MA square by 6 plus MA square by 2, 4 MA square by 6. And we get 2 MA square by 3. Here it's a direct question. To calculate force exerted force between M1 and M2 is F is equal to G M1 M2 by D square direct. D is effective distance between center of masses. The given effective distance is R. So Gm1 M2 by R square. Two waves having intensities are in the ratio So if waves differ by an angle theta, then so effective intensity is cos phi. For maximum, cos phi is 1. For minimum, cos phi here is -1. So I maximum will be root I1 plus root I2 whole square. I minimum will be root I1 minus root I2 whole square. So I maximum by I minimum, root I1 is root 9 plus 1 whole square. Root 9 minus, that is 16 by 4. One face of equiconvex lens is silvered. The radius of curvature is 40 centimeter. Refractive index is this. Object is placed at 10 centimeter from the side of the lens which is not silvered. Here, to find image of a object with respect to silvered lens, we have to find effective focal length. What does it mean by effective focal length? Suppose if lens is not silvered, then object is placed here at two different places. Successive refraction occurs somewhere, image will be formed here. Suppose here, if you consider a lens which is silvered, at one face, object is placed here, or okay, let us take a point object. A refraction occurs, and then now it is silvered. It reflection occurs here, so somewhere again refraction occurs. Somewhere we get a image here. So that means here two successive refractions and one reflection takes place. So finally, lens means your object is formed, image is formed other side of the object, whereas here image is formed the same side. That means finally, after silvering, it behaves like a concave mirror. So one power is equal to power of a lens plus power of a mirror plus power of a lens. So here it is. Power of a lens is combination of algebraic sum of powers. So here convex lens and power is defined as reciprocal of a focal length. For convex lens, focal length is positive. For a mirror, concave mirror, focal length is negative, power will be negative. So we write power of a lens is positive as it is. 2 by Fm minus 2 by Fl minus 1 by Fn. And finally, so effective combination behaves like a mirror, concave mirror. Right. So how do we find focal length of a lens? 1 by Fl is 1 by R1 minus 1 by R2. Since it is equiconvex lens, 1 by R plus 1 by R, because for this side it is R, for this side it is minus R, which is mu minus 1, 2 by R. Here it is 1 by FL will be 2 times mu minus 1 by R. FM is focal length of a concave mirror. So effective focal length, effective power, we can say here, that is 2 by FL, 2 times mu minus 1 by R plus 1 by R by 2. That is 4 mu minus 2 by R. So mu here, he given it as 1.5 minus 2 by radius of the curvature, 4 by 40, 1 by 10. Power here is minus, this behaves like a mirror. So focal length is minus 10. So finally, we should not use lens formula, we should use mirror formula, because finally after silvering it behaves like a mirror. Object is placed here, so 1 by V is 0. Image is formed at infinity. Here a particle is dropped from a height and another particle is thrown downwards with the initial speed u. Distance between one's freely falling body, it travels this much distance after t seconds. Projected body will travel. The difference will be ut plus half gt square minus half gt square. This is the difference. Here, electric field and magnetic field. So, amplitude of electric field and amplitude of magnetic field is related by this. So, B naught here is 18 by 3 into 10 power 8 meter per second. 6 into 10. But he is asking RMS, BRMS, root mean square magnetic field, which is B naught by root 2. 6 by 10 power 8 minus root 2. 3 root 2 into this. So roughly 4.23 into 10 power minus 8 Tesla. Here it is. The temperature coefficient of resistance here temperature varies, it's not a constant. So how resistance changes with respect to temperature? R2 is R1 into 1 plus temperature coefficient of resistance into delta T. Right. Initially, he told R naught. So here it is. After certain temperature, this is final. R naught alpha delta. This is change in the resistance, which is equal to R naught alpha right? Dt. So dt is equal to dr. Your alpha, how it changes. What we given is alpha of t, which is 3t square plus 2t. Alpha is dr by r naught dt. Dr is r naught, alpha is 3t square plus 2t dt. Now, when initially temperature zero resistance, we don't know resistance after certain temperature. He given R is the resistance. So then at at T, its resistance is R. R here, R naught 3t cube by 3 plus 2t square by 2 between it is R minus R naught, right? R naught into t cube plus t square minus 0. R is equal to R naught into 1 plus t square plus t cube.